Okay, so let's talk about EQ for a reason. The first point is about frequency problems. That frequency problems, right? An equalizer works with frequencies. If you have too much bass, too much treble, an equalizer is a good tool to cut or boost those frequencies. The three things that you first want to think about when equalizing are: start with the most important thing. Try to avoid equalizing in solo mode. You want to hear everything together and not have it be just individual parts. And also, if you have the choice between cutting and boosting, it's better to cut. Better to have less of bad frequencies than more good frequencies. So that's a question where the actual answer is all of the above. Okay. So the phase relationships in EQ can affect the sound. The way we actually do this process of boosting some frequencies and not others is using phase. We've done some of those experiments in Audio 1, and it's the same sort of thing is the way we're using on these equalizers to do what we want to do. And if you've got a signal chain where you've got an equalizer and you've got a compressor, but the compressor is not working exactly the way you want it, you might want to switch the order of them, right? Take and put the EQ before the compressor, and especially if you're getting rid of low frequencies. Low frequencies can really mess with gates and compressors, even though we don't hear those frequencies. All right, now this is a little bit complicated. I think this is a true-false question, and it's about when you're using an equalizer to do something subjective, something artistic, not the repair half of things where we're just trying to get rid of the sound of air conditioning or a truck that drove by. When you're doing something artistic and making it warmer or nicer or better, there is no exact right setting. If it does what you want it to do, then that's good. That's all we can ask for. Okay. There's another true-false question that has to do with the time domain problems as opposed to frequency domain problems. Whatever the question is, it's false. Really, if there are frequency problems, there are probably going to be time problems also. Probably gain, right? Probably dynamics, EQ, time, all of those things go into a mix. Masking. I think I mentioned masking earlier, but masking is this phenomenon where certain frequencies of one instrument will affect the other. Okay, even if you don't necessarily think they're even in the same range, they might be overtones or harmonics, where cutting a little bit out of a synthesizer will make the kick drum sound much better. Masking is what we hear whenever there are several instruments playing at once and they interact with each other. A peak filter is used to get rid of one little sliver of a frequency, right? Particularly resonance. If we get some particular frequency that's resonating in a room or in a studio, you can use a peak filter and just notch that little bit out. Okay. Each individual engineer will have their preferred way of working. So this is another one of these true-false questions where there's a right way and a wrong way, but no, that's not true. It's you have to find your own way of doing things, and every engineer has their own style. Okay. The last question is about equalizers working with frequencies that don't exist, right? I guess it's false that you can EQ a frequency that is not there. You can only equalize the frequencies that you captured, right? If you used a microphone that didn't get the low frequencies, you can't make it up with an EQ. It's not there to begin with. If it's a sine wave that doesn't have any overtones, right? You can't boost those into existence. We have other ways of doing some tricks, but not just an EQ that will create them. Okay, well, I hope that was helpful. And remember, like the kangaroo says, at these prices, I'm not surprised.